It's working on it. There, I hear you whispering.
I know, I've got my and I'm like trying to switch it over. Let's see. Hello, hello.
Hey, Aisha.
Hey.
Hey, it worked. Okay.
Yay.
Awesome. Awesome. Okay.
How's it going?
Good. I had a panic attack when I was like, I hope she didn't mean 11 Eastern time.
No, I try to remember to translate for you.
Thank you. It usually does it automatically, but I have had that issue a couple of times this summer where I'm like just tootling around the kitchen and I'm like, oh no.
Yeah, it's like, wait a second. What time?
Yeah.
Aisha, how are you doing?
Good. How are you?
Good. What's the word this week in Cobb County?
Still the same. Teachers go back the 27th of July. Students are going back as of now. Yeah. I don't know. That might change. We'll see.
Yeah, that's crazy.
It is crazy.
Are the teachers there kind of having a moment? And in Texas, teachers are freaking out, and I don't blame them.
Yeah, we are.
Yeah.
Because all the focus has been on like what's best for the kids. And I'm like, well, okay, I get it. But also teachers, they're not just expendable babysitters here. You know, you don't just get to like put it all on them. So I'm a little worried.
Yeah.
Right. Yeah, I don't know. And then I've seen a lot, my friends in Gwinnett County have been posting about all the negativity that's on the Gwinnett page as far as like teachers. And it's like, remember you guys were like praising teachers 2 months ago, parents.
Oh yeah, we can't pay you enough to do our kids. And yeah. And now it's like, anyway, open up the babysitter again because we're done with this.
Right.
Yeah, I know. I feel for and the teachers with young kids, like,
Yes.
it's completely unworkable. I don't know. I don't know what the solution is, but it's all around bad. Goodness.
I don't know. Hopefully enough of them will stay home that social distancing will be possible.
That's what I'm hoping for too.
I'm just wondering how they're going to quarantine. You know, they keep talking about quarantining if there's a positive, you know, if a kid shows up and is infected and they're talking about quarantining. I'm like, that's going to be all year then. I mean, there's just no escaping that, right? Like,
exactly.
I don't get a week or two of school, and then especially in high school when they're rotating around to 8 different teachers.
Mm-hmm.
I don't get it.
Yep.
It'll be interesting.
Cool. Got some more people join in.
Yeah.
Hey, Tiffany.
Variety of things that, quote, take advantage of people, but
There's Tiffany.
Sorry.
That's all right.
Hey, Tiffany.
We're getting ready to go to lunch, so.
Yeah. And there's Felicia. Hey.
Hi, guys.
Julie joining. Welcome.
Awesome.
Cool. I'm going to share my screen. Yeah. There we go. Hopefully I can see everything. I'll keep an eye out for the chat. Let's see. So I'll just leave it in this view. Since this week we're just talking about preparation tips and tricks. So I wrote down some talking points since I didn't hear any questions back from anybody. But I wrote down some talking points so we can go through those. And then as you guys think of things, feel free to chime in. You can either just throw it in the chat, or if there's a lull in conversation, just shout it out. Just trying to help you guys out. So I'll leave it in this view so that I can type in as we come up with extra stuff. I left some notes pages. So first off, everybody that's on, we'll just go around and say who you are, what school you're at, and what you teach. So I am Megan Heafy. I am your leader for Innovate here. So I was a high school science teacher. I did 3 years in Forest Park High School in Clayton County, and then 6 at Duluth High School in Gwinnett, so Metro Atlanta. taught chem, bio, AP bio, etc. And now I work for the Georgia Bioed Institute, helping you guys with some teacher training and support. So let's see, where's my participant list? Who's next? Aisha's next.
Okay, hi, my name is Aisha Harrison. I teach at South Cobb High School in Cobb County. I teach biology and applications of biotechnology.
Welcome.
Thank you.
Felicia? Maybe you're muted.
Hello.
Oh, there you go. Hey.
Yeah, okay, I'll unmute. Okay, hello everybody. I'm Felicia Forbes and I teach at Metter High School in Metter, Georgia.
Better
Okay,
and
down
better.
in Southeast Georgia. Yeah, everything's better and better. We hope. But I've been teaching physical science and chemistry for 4 years. This year I'm going to embark on teaching applications of biotechnology, and then I'll teach essentials after that.
Awesome. Well, welcome to the group. And yeah, we have some super help for you. We'll introduce Lee in a minute and she can be your new go-to person. Let's see. Somebody joined on a phone that's 770-401-4954.
Hey, Megan, it's Cynthia. I can't get my Zoom to pull up. Can you resend me the link?
Yeah, I'll forward you the calendar invite.
Thank you.
Sure. Okay, Julie.
Hi, I'm Julie Throne. I teach agriculture at Cedar Shoals High School in Athens. I've been an ag teacher for 17 years. I teach just about all the classes. Currently, I teach animal science and vet science and plant science, which I incorporate some biotechnology into.
Awesome, welcome. Let's see, and then Lee is up next. And I did a slide for Lee. Where did Lee go?
Hold on. I'm on mute. Sorry about that.
Oh, there you went.
Hello. My name is Lee Brown and I work for Biorad. I used to teach honors in AP biology at a science magnet school in Austin. That's been forever ago, though I've been working for Biorad for 11 years. And so my role there is to work with teachers to help them just make science labs easier in their classroom. So we can talk about prep, how it fits into your curriculum. I've screwed up every lab we have all different ways, so there's no embarrassment in asking me or telling me that you've messed something up, because I guarantee you I've done it too. So hopefully we can give you some ideas to make your life a little bit easier, especially this next year.
Oh my God. Thanks, Lee, for joining us.
Sure.
All right, who's next? I think Lisa. Lisa, you're muted. I don't know.
She said her mic is not working.
Oh no. Oh, it's in the chat. I can't see. Well, if your mic's not working, you can type in the chat and we will check the chat and come back. Tiffany?
Hello, y'all. Tiffany Jones. I teach at South Cobb High School with Aisha. I do biology, anatomy, and a research class, and all of those classes have a biotech component within them. So kind of branch out and learn some more.
Awesome. Cool. And then I think 770-877-1399.
Hi, my name is Tiara White. I teach at Dooley County High School, chemistry, physics, and physical science.
Welcome.
Great.
Awesome. So we got a good group today. And Cynthia, I skipped you.
Okay, I'm sorry. So I'm Cynthia Greer. I teach at North Hall High School in Hall County. I teach any biologicals and I teach biotech 1 and 2.
Awesome. Did I get everybody else whose mic is working? I think so. And Lisa said she's from Griffin High School, trying to integrate biotech into her course, environmental science. So welcome, Lisa. All right, cool. So I made a quick agenda, and again, this is to get you guys some conversation about this and ask questions as they come up. So feel free to jump in. If you want to pop stuff in the chat, we can go back to the chat. I pulled it up over here so I can see it. And I just put down some topics that we can talk about today that I thought of. I went through ways that I've botched things and started with those. Let me move to the next slide, maybe. There we go. We already said hey to Lee, but I left her email in here. So if you guys need her, feel free to email her. And I'll send out the PowerPoint later to our list, so you guys will have it. All right, so the first topic I went through was pouring plates. I did all the pGLO kits for the January training. I also did pGLO several times in my AP Bio class. So I wrote down a couple things that we've talked about, and Lee's been doing the CRISPR all summer. So she pointed out she's been pouring plates super thin. So if you, you get your packet and you only have so much LB, you can definitely get away with just a tiny layer. They only need a little bit of food to survive those bacteria. So feel free to pour them as thin as you need to. I have messed up the pGLO kit so many times. Leah's messed it up way more. But so the kit recommends that you make the plate 72 hours in advance and then place them in the fridge, but I have definitely done it the afternoon before with like 12 hours to go and it's worked. So just leaving them out on the counter, they're fine. I never put them in the fridge in my classroom because I didn't have that much space. Steps that you have to listen to are the ampicillin. I think it was 55 degrees, Lee.
Yeah, it's basically when you can hold the flask. I never use a thermometer because I figure the thermometer's got bacteria on it. And so I just hold the flask. And once I can hold the flask comfortably, then I just add the ampicillin. So
okay, that's fair. Yeah, and then swirl it around. We'll go with when you can hold it. Hold flask. So, and then the arabinose, you're supposed to wait till it cools a little bit more and add that, but there was definitely at least one time that I forgot to do that. And so I looked at the end, I still had my vial of ampicillin with all my plates sitting there. And so I just put back and put a little on each plate, spread it around a little bit, and it worked just fine. So it's a really forgiving.
For the arabinose, the other thing that you can do is, and actually we're working on how to do this in general biology classes, like 9th grade in particular, to stretch it even further. And so some of the things that we've done are, normally they need 4 plates, but we were just looking at doing 2 plates, and they divide each plate. The plates are like this big, and they just draw a Sharpie line down the middle and plate 1. They do 2 tubes on 2 plates each. And so they would do 1 tube on each of those 2 plates basically, and then add arabinose on top like the next day.
To turn it on later.
Yes, and so I don't know how much background y'all have on pGLO yet, if that makes any sense at all, but arabinose works like a switch to turn on the production of the green fluorescent protein that they'll see. And so it kind of helps them understand that it is a switch that they can actually add to it and then turn on the expression of a protein, which is kind of cool. It works either way. The way that we have it written in the manual is that you put arabinose at the switch in the medium when you pour it. But if you add it on top, that's not I think it's almost a little bit better for the students. I also wanted to show, Megan, can I share my screen real quick and I'll show you guys the video?
Yeah, I'll stop sharing real quick.
Okay, so, what happened here? Oops. Let me go back to Zoom. More. Well, nuts. Now I don't know where do I share my screen? Oh, am I sharing my screen already?
No. The green button at the bottom. That says
here it is.
There it
goes.
Didn't
have it. I didn't have it fully on. So let me share my is this showing you guys YouTube right now? Yeah. Okay, great. So and I'll put this in the chat as well. So you have it, the link. These are the playlists for all of our labs. And some of them are our videos that we've done, and some of them are just, like Bozeman Biology and Amoeba Sisters and things like that. But this section right here, laboratory technique how-tos, if you go, Megan, have you already shown them this? I don't want to go over this if it's too much, but there's one on pGLO right here. And this particular video walks them through the actual student portion of the lab, which is really nice. It's designed so that you can assign it to students ahead of time if you want to. But there is also a video on how to pour media. And let me see if I can find that just to show you guys. Product related videos. Let me just look here and see. Let me look. The other thing I'll often do is just search for Biorad, pour media, and sometimes they'll come up that way. There we go, this one. So this one shows you how to pour plates. And like Megan was saying, when you're pouring your plates, if you pour them thin, I want to get to the part where he's pouring plates here.
Actually pouring, yeah.
Okay, so right around here. And this is all narrated, so you can see he's telling you where to label. Oh my goodness, is he ever going to get to the point where he's pouring? Oh, here we go, way down here. It does not take this long normally. So when you're pouring, at this point, you don't need to measure. You're just going to pour, and to pour your plates thin, I would stop right there before it actually covers the whole bottom. And then you're just going to swirl it and it'll cover it. Okay, so that when we say pouring thin, that's what I mean. This is twice as thick as I would ever pour a plate. Now, the kit that what comes in the box is designed for you to pour them this thick. But if you want to stretch it, you'll need to buy more plates. Okay, but then you can stretch it and you'll have those plates for 3 more years, really, or something, you know. So just FYI. Okay, sorry, I just wanted to show you that that existed.
Thanks.
So I will stop and send it back to you.
Cool. Yeah. And then I'll paste that into the spreadsheet or the PowerPoint before I send it out.
Great.
So, thank
Great.
you. Cool. Now, well, that's new.
I know you have to go back to the full screen to see the share screen. It's really.
Well, my Zoom is like, Zoom isn't responding.
Uh-oh.
Program to respond.
Oh, no.
That's cool. Y'all talk amongst yourselves.
She has to re-give you permission since you.
Oh, maybe that's it. Let's see.
Leah has to give you the permission back.
Okay, so you have to stop share.
I did stop, but let's see how I get back to the.
I'm gonna close some of my other stuff that's open too.
I don't know if I have a way to give you it back. It's not just giving you back the, let's see, more participants, invite. You should still be the host. You should be able to do it.
Yeah, I think my Zoom is having a fit at the moment. That's fine.
If you go to the, if you blow us up into the main screen, do you see that button again? That's what I had to do.
Nope. No, my whole Zoom meeting window is like gray. So I think it's hilarious that it's letting me talk to you still.
Oh my gosh. Do you want to go back out and get back in? Or will that close it for everyone?
It might close it for everybody. This is fun. Technology is fun, guys.
Isn't it great? I love it. That pGLO kit is from Biorad, just to answer some questions in the talk. And I can, here, I'll share my screen again while Megan's figuring stuff out.
Maybe I will try to close it and then come back.
Yeah, close
Seems
it and
like
then
last resort. All right, y'all have fun.
We can all meet back up if we all disappear. Okay, so I'll show you guys the lab. If you go to our site, and I can post the direct link here, there's these pGLO bacterial transformation kits, and it's just this one. It's $99. It's designed for a class with 8 workstations. I don't know, how do you guys, I know we're all kind of like a big question mark for the fall, but what do you expect that your fall might look like as far as labs go? Are they, are you thinking that you'll be able to do labs as you've always done them? Are they wanting you to do maybe individual workstations, or no idea?
No,
we don't know. Okay, that's how we are too. Yeah.
We know nothing.
Mm-hmm.
But I'm
We
thinking
have parent
individual.
surveys going out this week.
Okay.
I'm thinking that the students will have to work individually. I'm thinking, but I'm not sure.
So that's the other thing we're working on right now, and this is where it helps for us to get feedback from you guys is we're working on a new set of prep and directions for you guys to aliquot and divide up the supplies so that they could be on individual workstations if that's, you know, and so it would be something like how to stretch the kit, you know, using 2 plates instead of 4, dividing them in half, you know, it's maybe not as optimal, but it's safer, you know, I mean, so if that's helpful, please let me know because we are working on that aspect as well. Were you able to get back in, Megan? I see you back.
I'm here.
Yay!
I had to
Okay,
force
nice.
close it. I saw there were 2 of me at one point, so that's fun.
I'm going to stop sharing and hopefully you can do it now.
Okay, yeah, let's see. I have like minimized and there we go. Okay, share. There we go. We're back
Awesome.
to our, all right. And then I'm gonna add, of course it deleted my entire chat, but I'll put the YouTube videos from BioRad in here. Okay, cool. Sorry for the interruption. That is a new one. So I'm no longer a host, I guess, but whatever. It's fine. It's fine. Okay. Yeah, so then a couple other things I had written from pGLO that we've chatted about. If you don't have micropipettes in your class or you don't have enough for your kids, it's okay. So you can use those disposable pipettes for most everything that you're doing. And then just for the plasmid is the only part that requires 10 microliters. But the loop is about the right size to give you 10 microliters. So if you get a nice film, like you're making a bubble on your little wand, you should have about 10 microliters of plasmid in there.
Hey, Megan, I have another tip for this that you can add. And this has come out of doing the trainings that are remote. So I'm mailing people plasmid. And as you can imagine, 10 microliters in a tube is just non-existent.
Yeah.
So what we've been doing is putting 10 microliters of the plasmid in a tube and labeling it plus. And then they add their transformation solution and their bacteria to that. And so that way we don't have to worry about them spinning it down. There's no pipetting involved. You can even do that with a loop if you're careful. I would only really recommend doing that though if you had a pipette. So if you have one pipette and you can pipette in 10 microliters and label that tube plus, they know that that's the tube that has the DNA in it. And it saves you a step, because that's also a bottleneck step as well. So that saves you time. Because normally the way that the protocol is written is the students are going up and getting 10 microliters from the same bottle. And so, you know, if you've got 30 kids in there or, you know, 8, at least one person from each group going up, it just takes time. So that cuts down at probably a 10-minute bottleneck, I would say.
Yeah, definitely. That's how I did mine in my class. I was like, well, it's such a tiny thing and we need to make it stretch. So I would do it for them so they don't have to come up and
so, but you can actually aliquot it even beforehand.
Yeah.
So
then I guess just put them in the fridge.
Yeah, it doesn't need to be. I mean, plasma is super stable, so you could put it in the fridge. If you aliquot out their transformation solution, you can just put it in the fridge with that, or you can, you know, basically then instead of 2 empty tubes, you're giving them 1 with plasmid and 1 empty tube. So, cool. And then they just add the transformation solution, add the bacteria, and then they're done. They don't add plasma because it's already in there. So,
yeah. Cool. So they just cross out that step when they get to it.
Yep, exactly. Yep.
Awesome. Thanks. And then last one, if you don't have an incubator, it's okay. They don't have to incubate. You can just leave them over the weekend at room temperature. So, and depending what the room is like, it may take a little bit less time or a little bit more time. But so you can do the lab on Friday and check them again on Monday. That works. So any questions so far or comments anybody else wants to share? Oh, bye, Cynthia. Yeah, I'll send you the PowerPoint.
Thank you. I'm sorry. I just got a call and I got to go help a friend out.
It's okay.
But yeah, if you'll send me this, that'd be great. But at least I know this one. I've done this one. You were there. You saw my kids high-fiving when they figured it out. But I would have to say that the BioRad kit is the better of the kits because I have used other ones and they didn't work. And the instructions are terrible on the other ones. BioRad, it has much better instructions. I will say that hands down. And I make my kids do everything. I don't do any of the lab. They do it all.
Nice. Yeah.
Congrats to BioRad, but I do have to leave, so sorry.
Yeah. Thanks,
Bye.
Cynthia.
Thanks.
Thank you. Bye.
Bye-bye.
Cool. Okay, so any other comments on pGLO or microbiology, swabbing, questions?
I've never done pGLO with my students, but I am looking forward to doing it one of these days. And this is very helpful. Like these little tricks and techniques are helpful.
Awesome. Cool. Thanks, Lee, for posting it again since my chat crashed.
No problem. The other video that's really helpful, and it's in that playlist, is I'm just gonna or Megan, you can go there if you want, but if you look at the Bozeman Biology AP Lab 6, he has a good overview of kind of the science behind that lab and how it works. I also am happy to do, I think I'm going to plan to do this at some point, just a video of me going through our PowerPoint presentation. And I can plan to do that. Yeah, look at Bozeman Biology AP Lab 6. That's the one that has pGLO, and it also has a restriction enzyme and gel electrophoresis lab. But this covers what's actually going on in the lab itself.
Especially.
Yeah, you got, I know this, YouTube is gonna make a killing this summer.
Yeah, they are. So he walks through the whole thing.
He walks through the whole thing on expected results and why. And so that's a good overview right there, I think. And then the other thing I'm going to put in the chat is our my Dropbox, which is oh, it didn't hyperlink it for some reason. I don't know why. Maybe it doesn't recognize that as a.
Well, you can copy paste.
Yeah. And so that has my, if you go in the pGLO folder, you'll see my PowerPoints that I use. You're welcome to edit those and change them however you want. But those are the ones I use for training teachers. And so oftentimes, because the ones I use are for training teachers, there are some slides that you probably want to drop for students, you know, just like about prep or whatever. But feel free to dig in there and kind of go scroll down. I think it's under pGLO bacterial transformation.
Oh yeah, they're labeled well.
Yeah, so there's a good bit of stuff in here. There's some pictures. The other thing that we'll work on doing is adding, again, because we really don't know what the fall is going to look like, we're trying to get just data sets. So pictures of different plates, and, you know, I'm not sure the best way to share this, maybe in a PowerPoint or something, but the idea is to have those plates so that you can show your students and they can kind of predict, or they can say, oh, this must have come from this plate, and explain why, right? Mm-hmm. Just in case that we're in a situation where they don't have access to the lab. So anyway, we'll see. These are some from that picture that you were just showing was from a workshop that teachers were in. So those are kind of what you would expect. I mean, you know, and they did different things to the different steps. They were tweaking the steps. So they did shorter, longer heat shocks, or different temperatures, or things like that, to see how it affected transformation efficiency. So that's what they were doing.
Nice. Yeah, so that's one extension if you have the time and the resources, is have them try out different conditions.
Yep.
So I'm putting your Dropbox, and it threw out the giant creepy link, so I'll put that in there.
That's my lab
Cool.
partner.
Oh, hey, Winston. So helpful.
Yeah, super helpful.
Oh. Okay, so I did put those in here, so you guys can go back and I'll share that later. All right, we did that, pGLO. Making gels, so as you're doing gel electrophoresis, the kids are gonna mess them up a lot, so it's okay to remelt them. So it could, you know, some evaporation could happen and you could lose some of your buffer that way. So you can add a little bit of water back in, just a bit, because the actual like buffer reagent should still be in there, but the water may have evaporated off. So it's okay if they like are pulling their comb out and they break it, just have them melt it and redo it. It'll be okay. They're pretty forgiving. With gel electrophoresis, if you don't have the big boxes, which we do have some that Georgia teachers can borrow, but if you don't have the big ones, you can make the little stem boxes, and those work really well, especially for an intro one with dyes. So you can have them separate out dyes in the gels, and that one works with a series of 9-volt batteries. And Bio-Rad does sell the DIY stem electrophoresis kit, but it was back ordered in the spring, so I got really handy at buying soap boxes off of Amazon and leads off of Amazon and 9-volt batteries, since we weren't going anywhere because of COVID, and making them in little boxes. So if you guys want some information on that, I can help you with that at some point. Yeah, anybody have any, you've done gels and something else happened to them, or?
One of the things I used to do, especially if you're doing like Skittle dyes, you can do Skittle dyes, just put a Skittle in a little Dixie cup or a medicine cup and add a couple of drops of the buffer that you use to run the gel. And it just knocks the dye off, you know, swirl it around and you'll get like red Skittle juice, you know.
Mm-hmm.
You can have one class, like if you're doing this with multiple classes, you can have one class run those and just run them right off the gel and just leave the gel in for the next class. You're not running anything, you know, that you're going to publish in a paper or anything. So you don't even need to do anything to the gel. Just make sure that there's buffer on top. You might need to add a little bit more buffer because it'll evaporate over the day. But that'll save you a lot of pouring gels. Now it's different if you're trying to teach them the skill of pouring gels, and that's a valuable skill too. But, you know.
Yeah. Cool. Awesome. Any other questions or thoughts?
Oh, Megan, the other thing I was going to say is that the buffer can be 0.25x. And so the buffer for making a gel has to be 1x. The buffer for running the gel can be 0.25x. So cut in like 1 part buffer to 3 parts water. And you can run it faster that way. So that helps you with getting it through the class. You know, you could run it at say 200 volts easily if you're in a commercial gel box with a power supply.
Awesome.
You can't do that with the 1x because it'll get too hot and it'll melt your gel. So you have to cut that buffer concentration down if you're running it fast.
Yeah. Okay. So can run at higher voltage. 1x buffer will melt gel. High voltage. Cool. Making notes. All right. So I put in some about mixing reagents. I've been doing the Kool-Aid chromatography a lot, and so I don't know why we have like 4 different concentrations of isopropyl alcohol in my house. So that lab requires you to do, I think it's like 25 and 5% or something like that. And so that fabulous chemistry equation comes in handy. So if you guys ever need help walking through that, I did chemistry for a long, long time, so I'm happy to help with that. But I did put an example here, so you can have an idea of what's going on. So since C1V1 works with whatever concentration, you can do percentages. So if you were starting with your 71% isopropyl and you need 25, you can set it up like this, figure out how much of the 25 you need, and then work backwards. So here for this one, I would need to add 35 milliliters-ish of 71% alcohol. And I don't have beakers sitting around, so I've been using shot glasses with the measurements, like making cocktails, to measure all this out. And so you add the 35 milliliters of the 71% and then just fill it the rest of the way to the 100 milliliters with water to break it down. Preferably distilled, but I think I've been using tap water and it's fine.
So you're saying you can use tap water if you don't have distilled water on hand sometimes?
Yeah. So there are some situations it can start to be a problem, but if you were working in a real lab and trying to get real results for a paper, then yes, you would want to make sure you're using distilled water. But if all you have is tap water, a lot of this stuff, I think I made my pGLO plates with just tap water most of the time. So because I was like, oh, I need to do it this afternoon, I don't have it, sink water it is. So yeah.
The only time I've seen it be an issue with sink water is I made buffer for a different lab, and for a protein electrophoresis lab, and it has a lot of SDS in it, and it precipitated out. And so that's really the only time I've seen it be an issue. We usually just ask you to do distilled water because it's sterile, So I just get it in gallons at the grocery store. That's what I do. In fact, I just make my buffer. I think it's something like 78 mils of 50X and a gallon of water to make 1X or something like that. I'll have to look it up. I can't remember off the top of my head. But I just take the water out of the gallon, put the amount of concentrated buffer in there in the gallon, and then I have a whole gallon of buffer. And it'll last forever. So, yeah.
Cool. I'm going to put Lee said, not protein electrophoresis.
Yeah, that's the only time I've had it precipitate out or cause an issue.
Cool.
But usually, like with pGLO, you're boiling it, so you're sterilizing anything anyway. So yeah, that's, the other thing that I will say, and you guys, it's not a biotech lab, but it is one of our labs. We have an algae lab, and the chlorine in tap water will kill the algae. And so that's the other time that you want to be careful, is if there's something living that the chlorine would kill it.
Okay. And tap water could kill algae or other living. Cool. But yeah, so for most of your applications in biotech, tap water it's okay.
Yeah.
Cool. All right, so moving on. So I just put in a little bit about suggestions for how to get some help, because lab prep is time consuming. It definitely is. A lot of times I've had students that are just interested, or they want to hang out in the afternoon anyway. So it's like, well, hey, do you mind putting yourself to work? And most times they're fine with it. We also had Beta Club at our school that they needed volunteer hours. And so we set it up with Beta Club that there would be a couple of volunteers that would come clean my lab on like a Friday afternoon, basically. So you could get them to help with lab prep. It would be a great thing for them to kind of put on a resume that, they've been helping you to prep labs and learned about how to mix reagents and all that. So ask for help. It's okay to ask for help. And then I had talked to Elizabeth Proctor a while back, and she said that she has students that are in her class as an internship. So they're lab interns. And so they do all of her lab prep. She does like QA with them. They get graded based on how well their reagents do. If the kids mess up, if it's based on the reagents, the interns get docked in their grade. So it's super cool. But she gave me the CRN codes for those. So those are posted here. So there's one for intern and research, and then there's a different code for, they use the medical laboratory technology lab tech intern code. So I think, I don't know if you can use that if you don't have a biotech class, like if you don't have the CTAE healthcare pathway at your school. But you can check, ask your, ask in the counseling office, I guess. So have you
Yeah.
guys?
I just wanted to say, this is Felicia. I just wanted to say that I have, hopefully it'll come through for me. It was a former student from who had the class before, who actually wants to come and do so like a TA, to be a TA for me. I hope that really happens. This is my first time teaching. Yeah.
Yeah, fingers
Great
crossed.
experience for them too. I mean, and I think that's you know, that is something they can put on a resume. It's a lot of work for them, and it's a lot of responsibility too. So yeah, that's great. I think if they're planning on going into biotech at all, you know, I'd be thrilled to have a student that knew how to do all that stuff and had done it more than one time, right? That's the thing is it's real experience. It's not just we did a lab about it once. So yeah, that's awesome.
Awesome, thanks. Well, hopefully that works out.
Yeah, we hope.
So up in the air right now. Anybody else? Have you used your students for volunteering in your classroom? No.
I have had student interns before, but I am a CTAE class and I have special sections that allows for them to be in a standalone class by themselves. I have ag management, which allows for an intern to be in my class. Also, there are academic internships. You should check with your school.
Right. Yeah, it might vary from school to school.
Yeah, because academic interns can also go into your classrooms and intern. But I would stay away from work-based learning or youth apprenticeship because there's a lot of paperwork involved with that.
Okay, yeah, that's fair.
One of the teachers that, well, actually it's Kirk Brown who wrote wrote our biotechnology book. But when he was doing this, when he first started his biotech course, this was in California, in a real rural area of California. It's like 60% migrant worker children that are there, kind of inland. And he had, you know, 3 years of biotech students in the same period, which was 0 hour actually. And what he did, and this was after I've been going for, you know, several years, but his second year students would train the first years. And so they were there showing them hands-on how to pipette and how to, you know, checking their work and things like that. The third years did all the lab prep for all of his classes, not just biotech, but AP biology, IB biology, all of that, and kept bacteria cultures going and all that kind of stuff. And then they were all doing science projects the whole time too. But it was a nice model of actually what you would expect to see for students that wind up going into a four-year university and may do undergraduate research. That's exactly how an undergraduate or a graduate level lab would go, is you would have, you know, your primary investigator, which would be the teacher, kind of overseeing things, but not really getting down and dirty in the lab work. That's the duty of the grad students, the postdocs, and they're training the undergrads, right, or the new graduate students. And so I thought it was a really good model of how to do a biotech course without being like, oh my gosh, I have to prep for 4 hands-on labs a day. Don't do that, right? Like get students trained to that point where they can do that, take on that burden for you. I just thought that was a genius idea. I wish I had thought of when I was teaching.
Yeah, right. They love to be put to work and help their classmates or tell their classmates what to do. So
and it gives them a reason. They're not just making media to make it, they're making it because their student, you know, their peers need it for their labs, right? So it gives them a reason to be really careful, and you know, that QA/QC stuff becomes really relevant.
Yeah.
Students do love help, and I often have students ask me if I need any help. Like I'll have volunteers ask me, do you need me to do anything? Do you need any help, Mrs. Harrison? So sometimes I'll put them to work, like cleaning the lab supplies, and I've never had them prep for lab, but I may start.
Yeah,
having
start a
them-
list.
Yeah.
As long as you have them trained, you know, that's the work that you put in at the very beginning, is getting them to the point where you trust them that they're not going to contaminate, or that they really understand how to use a pipette, and they understand C1V1 equals C2V2. They know how to do that. So there is a lot of initial, you know, training of that, at least for that first group. Yeah, but it's in the long run, it's got to pay off big time.
Mm-hmm.
Yeah. Awesome. I wrote down some good ideas, so I'll write them in the notes section too for you guys a little bit later. So I think that was about all I wanted to go over today, unless you guys have any extra questions. Feel free to toss them in the chat. So the next couple sessions, we have 2 more weeks. So next week we can do some brainstorming about how to get biotech into these other classes. So we've been talking about biology, ag, all those things. So talk about different ways, and maybe you guys can just bounce ideas off of one another and say, I want to incorporate it here. Oh, here's something awesome that you can do. And we can send some resources around. And then week 5, we can do a little bit, hopefully by then we have a better idea of what's happening in the fall. It sounds like it's still kind of people tossing ideas in the air and coming back to them. So we can come up with some kind of contingency planning for what if we start out in person and then we have to go online. How are you guys going to handle that curriculum wise? And maybe break it down by subject. So have all the biotech 1 people talk, and then biotech 2, etc. If you guys have specific things you want covered, feel free to email them to me. Coolly put another classroom resources in the chat. Thank you.
Those are just all of our labs, and so there's stuff there that I think might come in useful, especially this fall. We try to do some of the paper modeling activities and things like that and highlight those. So if you're looking for alternatives to in-school labs, all the ones that we have are on that page.
Awesome.
Yeah.
And I had been putting some together on the Georgia Bio site, so I'll share that in the PowerPoint later. So Georgia Bio Ed, we have a teacher resource page going. So a lot of it is BioRad stuff where I took
I was gonna say, feel free to link to any of that from there. That's all, it's all, I mean, y'all are welcome to take it, change it, do whatever.
Awesome. Okay.
And I'm going to put my email in the chat as well. So you guys are welcome to get in touch with me. It's super weird. I'm normally traveling like 80% of the time, and now I'm home all the time. So
I know your response rate is
I'm
so
a lot
much
more
better
available.
Takes like
Oh my
30
gosh.
minutes for a response.
Yeah, I know. It's like, I'm gonna be out of the country for no, not usually out of the country, but
yeah. Well, I'm glad you could join us and that you're not traveling nonstop right now.
I am too. I am. I'm sure at some point I'll miss it, but it hasn't happened yet. I miss
Your
seeing
dog
you
is not
guys.
complaining.
Yeah, no, Winston's definitely loving it. Yeah, for sure. He likes having a work from home partner.
Aw.
But yeah, you guys feel free to email me if you have questions that come up. I mean, like I said, there's no question too silly to ask. I guarantee you I've done it. So, and if there's things that you can think of that you want us to help you with, we're all kind of in this weird situation where we're like, our jobs are looking very different than they did this time last year. So we're trying to figure out how best to help you guys. So if there's things that resources that you need from us, we're working on videos right now that are really designed for teachers to kind of explain some of the labs to get you guys up to speed and understanding more comfortable, things like that. But if there's things that you'd like to see, like prep videos or prep PowerPoints or that kind of stuff, just let us know and we'll work on trying to get some of those done.
Thank you.
Yeah. Thank you guys.
Yeah. And thank you all for attending. So I have all of our kind of contact information here for Georgia Bioed. We did just set up a new Instagram, so it's not actively posting yet. But if you want to go ahead and follow it on Instagram, we're going to start to kick off posting some stuff about our new depot. We'll do like a virtual depot day thing, probably. We're aiming for late August, so once y'all are back in school, it'll be kind of after school hours. So a virtual walkthrough of the depot. So our nice new space, it's exciting. But yeah, so keep in contact, reach out. You can reach out to Lee now, but also feel free to reach out to me if you have like a ton of stuff that you're looking for. We'll help you out. We're here to support. So, and hopefully make things as easy as possible for you guys going back in the fall. So I know that's not going to be easy, and it's all up in the air, but we're here to help with whatever happens.
Megan, I have we have, I think 2 weeks from now, or 3 weeks, I think it's 2 weeks from now, we're gonna have a Q&A with scientists. I'm just gonna post the form in the chat, and this is it's an Innovate, I think it's 3 weeks from today or from Thursday. There will be kind of like a exhibit, I don't know, business exhibit hall. I don't know if that's the right word for it, but I think what a virtual fair, right? A virtual exhibit hall, right?
Yeah.
And so what we're going to do is a Q&A with our R&D scientists. So I'm just posting that there. If you have questions for our scientists that you'd like to ask, or from me, I'll be there too. If you want to submit them ahead of time, and they can be questions about anything. It could be COVID related. It could be, stuff about our products or not, or just what it's like to work in a biotech company. Any of that, we would love to get a few questions just so we can answer stuff that's relevant for you guys.
Yeah, start the conversation.
And that's like 3 Thursdays from now. It'll be in the Canvas and all that good stuff. So
cool.
But yep. So I just posted that there. You're welcome to take a look, and we won't call you out by name or anything. We'll just try to make a slide about it and answer some questions. So
awesome. Yeah, that should be good too.
Yeah.
Thanks, Lee.
Yeah, thank you guys.
Cool. Do you guys have anything else? Well, and I'll hang out for a little bit now that I'm not kicked off. So if you have any extra questions or anything, just let me know. But feel free to email me. I'll put my email in the chat again. If you're like just in the middle of the night, you're like, oh, I thought of something that I really need, just send it over. We're here to help. So otherwise, y'all have a good day. Go stay dry. It's raining on and off, and stay safe.
You too. Thank you so much.
Bye, guys.
Thank
Good seeing you.
Thank you. Thank you so much. Bye-bye.
Bye.
Bye.